Hi, welcome to this lesson on trigonometry, trigonometric functions part 1. Let's have a look at question 6. We're given two diagrams, or two graphs below in the diagram. Graphs of f of x equals cos 2x and g of x equals negative sine x. So these are drawn between negative 180 and 180 degrees. They also tell us a and b are 2 points of intersection of f and g. So here's one and here's another one. If you take a look at the graph, you can also see there's a third intersection point as well. Okay, so before we move on to the questions, let's just analyze the graphs a bit. G of x just has one parameter affecting it, an a value of negative 1 in front of the parent graph sine x. So that tells us that g was a reflection of f of x about the x-axis. Alright, and you can see the green graph, that was a reflection because sine of x would generally look like this. Okay, so you can see it's being entirely reflected across the x-axis. And f of x also has only one parameter affecting it. There's a b value of 2 in front of the x, and that tells us that the original cos x graph now has a new period of 360 degrees divided by 2, which is 180 degrees. And if you look at the graph, the blue graph f, you can see that the graph completes one full cos wave in 180 degrees. Okay, so now it tells us without the use of a calculator, determine the values of x for which cos 2x equals negative sine x in that interval. So we're looking for points of intersection essentially. So let's solve this. Okay, so there's a few ways we could go about this. We could change cos 2x into 1 minus 2 sine squared x, for example. That would give us a quadratic equation in sine x, and we could solve from there. But I'm going to do it a bit of a different way this time. I'm going to use co-ratios. So recall that sine of x can be rewritten as cos of 90 degrees minus x. Okay, and if you look at the cos diagram, okay, if he has the angle x, then he has 90 minus x. Then if sine of x is y over r, and this is, let's say, okay, I've used the angle x, so I don't want to use the distance x here. Let's just say the distance here is a. Then sine of x, the angle x is y over r. And then the cos of 90 minus x is adjacent of my hypotenuse, which is y over r. So by co-ratios, I can replace that negative sine x by cos 2x equals negative cos of 90 degrees minus x. So why would I want to do it like this? Well, first of all, I've got it now in this form here. Cos of an angle equals a number. So if I have my cos diagram, and we imagine here's the number here. Okay, so it's a negative number, all right? And cos is negative in the second and third quadrants. So I know that the angle 2x is going to equal 180 degrees minus the reference angle, okay, plus k times 360 for the period of cos. So that's the second quadrant. And the third quadrant is going to be 2x equals 180 degrees plus the reference angle, plus k times 360. Okay, so now I need the reference angle. So how do I find the reference angle? Well, how do we do it in general for a trig equation? We take cos inverse of the number. So therefore, the reference angle is going to be cos inverse of the positive, so cos of 90 degrees minus x. Now, cos inverse and cos are inverse functions of each other, so they'll undo each other, and the reference angle you're left with is 90 degrees minus x. So that's the reference angle. So therefore, 2x is equal to 180 degrees minus 90 degrees minus x, plus k times 360. Be careful to put your brackets, because that negative needs to distribute out. So 180 minus 90 is 90, and minus x is plus x. Okay, so therefore if I divide both sides by 2 now, what do I get? Well, I'm not going to divide both sides by 2 actually, because there's a plus x here. I'm going to subtract x from both sides. So I'm going to get 2x minus x is just 1x, and it's going to be 90 degrees plus k times 360, where k is an integer. And then for here, we're going to have 2x equals 180 degrees plus 90 degrees minus x, plus k times 360. So now we're going to have 2x equals, so 180 plus 90, that's 270. minus x plus k times 360. Okay, so just make sure you're following your algebraic steps very carefully. Now I can move that negative x to the left-hand side. So that gives me 3x equals 270 degrees plus k times 360 degrees. And therefore, if I divide both sides by 3 now, I get x equals 90 degrees plus k times 120 degrees, where k is an integer. Okay, so I would use this one as the general solution because this one is also going to include all solutions of this one because they both start at 90. And the 120 degrees means that once I get to k equals 3, for example, I'm going to end up at this 360 mark again. Okay, so I would use this as my general solution. You can use both. Both will give you exactly the same solutions, but this one here will give you more solutions. Okay, that this one won't give you, the second quadrant. Okay, so now we need to find the x values. Okay, so if I put k equals 0 here, I get x equals 90 degrees. If I put k equals 1 here, 90 plus 120, that's going to give me outside of 180, so it's not applicable. And that's for k greater than or equals to 1. What about k equals negative 1? 90 minus 120, that's negative 30 degrees. And then k equals negative 2, that's going to be another minus 120, that's going to give you negative 150 degrees. These will be the three solutions, because if you keep going more negative, you're going to go outside that given domain. Okay, so let's go ahead and check if that makes sense. So negative 150, negative 30, and 90 degrees. So negative 150 will be here. Negative 30 would be over here. And the other one was 120 degrees. That would be here. No, not 120 degrees, sorry, 90 degrees. Okay, so those would be the 3 points of intersection, right? And you can see that A and B, we've actually found the x coordinates for those. Okay, so how many degrees apart are A and B from each other? So the distance between the two x coordinates of the degrees, which I'll denote by that magnitude symbol, distance between them, is essentially from negative 150 to negative 30. That's a total distance of 120 degrees. Okay, how many degrees are apart? We're not looking for negative here because we're looking for a distance apart. For which values of x in the given interval will f prime x times g prime x be greater than 0? So now we've got to be very careful here. We're not talking about the original functions anymore. Now we're talking about the derivatives of the functions. But we have trigonometric functions. So how do we work out the derivative of those? So there is a way we can actually find the derivative of these trig functions, but if you cannot manually work out the derivative of a trig function, then it's best to use a graph, which shows you where the graph is increasing and decreasing. Because remember, f prime and g prime tells us the gradients of the tangent lines. So if we come back to the graph here, all right, let's make some space here. So when the graph increases, so let's look at the green graph, for example. Okay, see, as the graph is increasing, the tangent lines are positive. It gets to a turning point where the tangent line is 0, and then when the graph decreases, you can see that the tangent lines are now negative gradients. And then when it increases again, the tangent lines are positive. But tangent lines are the first derivative at that point. Okay, the gradient of a tangent line is the derivative at that point of contact of that tangent line. So what we can do is we can essentially create what we call a sort of chart that maps out whether the graph increases or decreases, and then from there use those values to determine whether the graph is increasing or decreasing, and therefore what the derivative value is. Okay, so what I'm going to do is I'm going to just sort of bring the x values down here. Then I'm going to look at f prime x, and then I'm going to look at g prime x. Okay, and then g prime x will be over here. Okay, so we have negative 180 degrees starting off there. Okay, so let's mark it off in intervals of 90 degrees. All right, so we have negative 90 degrees. There's going to be a turning point here. Okay, so negative 90 degrees. then it's going to be 0 degrees, then it's going to be 90 degrees, and 180 degrees. Okay, so now let's test what's happening to the graphs. So for f of x, the blue graph, it's decreasing, it reaches a turning point, and then it increases, reaches a turning point, it starts to decrease again, reaches a turning point, and then begins to increase again. Okay, so what does that mean? So between negative 180 and negative 90, the graph is decreasing. So f prime x, the gradients of the tangent lines, is going to be negative there. Then between negative 90 and 0 degrees, the graph is increasing, so it's positive. Notice at negative 90 degrees, the gradient of the tangent line is 0. Okay? Then when you're going to get to 0 degrees, the gradient of the tangent line is 0. The graph decreases, so the tangent or the first derivative is negative. It's another turning point, so the tangent is 0, and then it increases again. So the first derivative is positive. Okay, because the tangent lines are positive. Let's use that same logic for the green graph, g of x. So you can see the graph is increasing, reaches a turning point, and then begins to decrease again. Reaches a turning point as well, and then begins to increase again. So where the graph increases, your derivative is also increasing. Okay, where your graph is decreasing, the tangent lines are negative, so the derivative is negative. Here, the tangent line at this point here, 0, it's either going to be negative, positive, or undeterminable, right? Depending on what the derivative is there. So we haven't explicitly worked out the derivative. Okay, so for now, we're just going to put there, I won't say negative or positive. We'll just leave it as it is. Okay, so from 0 degrees to 90 degrees, okay, the graph is decreasing, so the tangents are going to be negative. Okay, and again, there's a turning point there, so it's 0, and then the graph is increasing, so the tangent is positive. So the original question was when f prime x times g prime x is greater than 0. So we want to match up these negative and positive so that when we multiply them together, we get a positive number. So this first one here won't work. The second one won't work, but this interval here will work, and this interval here will work. But notice we can't have this one here, because here we're just going to have it equals to 0. Okay, and the same thing here. We didn't know exactly what the derivative was, but it doesn't matter, because when it multiplies by 0, it'll still give you 0. All right, so the interval that we are looking for is between 0 degrees to 90 degrees, but they're not including it. And then from 90 degrees again up to 180 degrees. So how do we write that mathematically? X is an element from 0 degrees, not including it, up to 90 degrees, not including it, union from that 90 degrees again to 180 degrees. All right, so that is how we would find those values there. And then lastly, determine the values for which cos 2x plus 3 equals k will have no solutions. So we have cos 2x plus 3 equals k. So there's a geometrical way we can do this and an algebraic way. So the algebraic way, I'll start off like this. I'm going to just get cos on itself. I just want the trig ratio by itself. So I subtract 3 on both sides. Now cos 2x, what is the range of cos 2x? That is between -1 and +1, because this here only affects the period. So the range of the cos graph still is between -1 and 1. Okay, but cos 2x is k minus 3. So I can substitute that in there. And now I can add 3 on both sides. So I'm going to get 2 less than equals to k less than equals to 4. Okay, so that is when the graph makes sense, because it's within its range. So this here, cos 2x plus 3 equals k, has no real solutions if and only if k is either greater than 4 or k is less than 2. Because that falls outside this interval. And if you have trouble seeing that, if you draw a number line, so let's say 0 is here, 2 and 4 is here, then between 2 and 4 is this number line here. That's between 2 and 4. So everything on the outside of this is when that graph will have no solutions. So that's represented by k is less than 2 or k greater than 4, where k is a real number. Okay, or you could write it like this. K is from 4 to infinity, or k is from negative infinity to 2. So the set builder notation would look something like this. Okay, either way you write it is fine. Okay, and then the geometrical way, cos 2x plus 3 equals k. So let's just make some space here again. Well, where is, so let's just get rid of all that stuff over here. Alright, so looking at this geometrically, cos 2x, we were given that graph. That was f of x. Alright, so f of x was this graph in blue. So the highest value here was 1, and the lowest value here was negative 1. So now, if I look at cos of 2x plus 3, that means I move everything up by 3 units. Okay, so now negative 1 going up by 3, that gives you a 2 here. So that'll be the new minimum. And then moving up from 1 to 3, that'll give you 4. That'll be the new maximum. Okay, so now, if we moved that graph up by 3 units, essentially we would have something that looks like this. Okay, and that's between 2 and 4. Now, if we let that cos 2x plus 3 equal some real number k, let's put it in purple here. Now k here, y equals k, is just a horizontal line. So y equals k could be here. Y equals k could be here. Alright, so can you see, if all these purple lines are below 2, the red graph won't cut it. And if all the purple lines are above 4, it won't cut the red graph. So that's the geometrical way. You can also check where the k values are. That won't give you any real solutions. All right, so you could do it both geometrically or algebraically. Your choice. Awesome. I'll see you in the next one.